Hello everyone. We will now work on the solutions of the word problems in project 2, starting with question number 13. It says here a police helicopter is flying at 800 feet above the ground. A car is sighted at an angle of depression of 72 degrees. Find the distance of the car to the nearest foot from a point directly below the helicopter. Now, the first step in solving any trigonometric word problem is to draw a diagram based on the description given in the question. Because once we can obtain a right triangle figure from our diagram, it'll be easy to model the problem, come up with a trigonometric equation and solve it. So my first step would be to start drawing the diagram, going through the question step by step, one sentence at a time. It says here, police helicopter is flying at 800 feet. So I'm going to first draw the ground here. And right above a certain point on the ground, there's a helicopter flying directly above. That means it makes an angle of 90 degrees with the ground. Directly above means it makes an angle of 90 degrees straight vertically up. There's a helicopter flying. Let me try to draw the helicopter here. All right, so here's our helicopter flying directly above at 800 feet. Now, in the next step, it says a car is sighted at an angle of depression of 72 degrees. So here we have a horizontal line of sight of the helicopter. And below there's a car, here's our car, and it is at an angle of depression of 72 degrees. So given the horizontal line of sight of the helicopter, the angle between the horizontal line of sight and the line of sight to the car is 72 degrees. That's the angle of depression. This is the angle of depression. It's the angle between the horizontal line of sight and the line of sight to the car below. That's 72 degrees, right? The question is to find the distance of the car to the nearest foot from a point directly below the helicopter. So the point directly below the helicopter is a point that is at 90 degrees to the ground. So let's mark that as angle C or point C. Wherever the car is, we label that as point A, which will also be angle A. And we have up above angle B where the helicopter is, directly above the ground. So now we have a figure of a right triangle. Let's label the different sides. The hypotenuse will be labeled with lowercase c. The side, which is 800 feet, is opposite angle A. So we label that as lowercase a. And the side opposite angle B will be labeled with the lowercase b. What we have to find is the distance of the car from a point directly below the helicopter. That means we have to find the length of side B in this rectangular figure, the distance between point A and point C. All right, that's what we need to find. All right, once we have the figure here, the next step would be to list our data points. We have been given the length of side A, which is 800 feet. We have to find one of the internal angles. We've been given the angle of depression, but it's the angle outside of the triangle. However, we can find angle B by subtracting 72 degrees from 90 degrees, correct? Angle B can be found by subtracting 72 degrees from 90 degrees. Let's do that here. Angle B equals 90 minus 72, which gives us 18 degrees. Now, this is not too perfect of a picture. The angle B doesn't look anything like 18 degrees, but let's just assume it is. So this internal angle is 18 degrees. Now we have one internal angle in this triangle. We know the measure of one side. We have to find side B, which is the unknown side. We can set up a tangent ratio equation using the opposite and the adjacent side to the angle which is 18 degrees, correct? So we will write this as tan of 18 degrees equals opposite side is B, that's the numerator, over A, correct? So let's plug in the values. B is the unknown side. A has a value of 800 feet. Therefore, tan 18 degrees equals B over 800. Solve for B. B would be 800 times tan of 18 degrees. So you multiply both sides by 800 to solve for B, and we end up with 800 times tan of 18 degrees. And now just use your calculator to find tan of 18 degrees, which is approximately 0.3249. When you multiply that by 800, you come up with a measure of 259.94 feet approximately. And it says rounded to the nearest foot. Therefore, we will have our final answer as 260 feet rounded to the nearest foot, right? And that's the answer. The distance of the car from a point directly below the helicopter is 260 feet. That's the final answer. Now, instead of finding B, we could also find angle A by using our knowledge of geometry that in two parallel lines, the horizontal line of sight from the helicopter and the ground, they run parallel to each other. Therefore, this hypotenuse of the triangle can be looked upon as the transversal between the two parallel lines, and the alternate angles in that case would be equal to each other. Therefore, if this angle of depression, which is the outside angle, is 72 degrees, then angle A would also be equal to 72 degrees. And then you set up a trigonometric ratio using angle A and its opposite and adjacent side as well. But whichever way you may have used, the answer should have been 260 feet. All right. We will now work on question number 14 in our project, which is also a word problem. It says here, a boat leaves the entrance to a harbor and travels 40 miles on a bearing of south 64 degrees east. How many miles south and how many miles east from the harbor has the boat traveled? Now, this is a problem involving directions and bearings. Therefore, we will draw a figure using the information given in the question first, and then we will try to obtain a right triangle to get a trigonometric equation to find the given sides in this case. All right, but let's try to understand what the question is saying and draw the figure as we go along. It says here, a boat leaves the entrance to a harbor. Let's mark a point which will represent our harbor, and it travels at a bearing of south 64 degrees east. So if this is the harbor, let me mark that with the letter H. I will draw a north-south line passing vertically down through this point, the harbor. Here is our north-south line, and a line across intersecting the north-south line at right angles. That would be the east-west line. West is to the left of the north-south line and east is to the right. So here we have our lines of directions or lines of bearing, the north-south and the east-west. The boat is initially located at the harbor, which we denoted with the letter H, and it says here it has traveled 40 miles on a bearing of south 64 degrees east. That means from the south line, from this line, it has traveled at a bearing of 64 degrees. Let's draw a line here. So this is the direction in which the boat has traveled, and it is at a point which is 40 miles from the harbor. That means the length of this line is a distance of 40 miles to the point where the boat is at present. I'll just mark that as B. All right, that's where the boat is. This is where the harbor is, the initial point where the boat was located, and we have the north-south line. Therefore, the question is, how many miles south and how many miles east from the harbor has the boat traveled? So which two sides are they asking us to find? They're asking us to find this distance along the north-south line, correct? I've marked that in red. That's the distance we have to find, which we can just write it as south. And the other one is how many miles east. Therefore, if the boat is located here, then this distance from the south line to wherever the boat is at point B. In other words, we are finding this distance here and this distance along the east line. So the angle south 64 degrees east is this angle here. We've just labeled that as angle H. Right? And we can mark the right angle as C. Therefore, the hypotenuse will be denoted with the lowercase letter c that has a value of 40. Now let's list our data points. Angle H in our case is 64 degrees. We don't need to worry about the south and east, the bearing notation at this point, because we just use the bearing information to get this figure correct. So angle H is 64 degrees. Side C is given to us as 40 miles, and we will first try to find the length of the side, which will represent south. All right, how many miles south? Given the angle and the hypotenuse, if we want to find south, then we will use our adjacent over hypotenuse ratio, which is the cosine ratio, correct? Therefore, cos of 64 degrees is equal to adjacent, which is the south side, adjacent over hypotenuse, which is the measure of C, 40 miles. Therefore, to solve for south, it'll be 40 times cos of 64 degrees. Therefore, south would be equal to 40 times cos of 64 degrees is roughly 0.8988. When you complete the multiplication, you will get a value of 35.95 miles. And if the question says round it to the nearest mile, then you will say 36 miles. So that means the boat has traveled roughly a distance of 36 miles south. Now we have to find the length of side east. This length we have to find. So we can use the sine ratio in this case, opposite over hypotenuse. Therefore, sine of 64 degrees will be equal to opposite over hypotenuse. Therefore, east divided by 40 miles. Therefore, to solve for side east, we'll end up with 40 times sine 64 degrees, which is equal to 40 times. Now, sine of 64 degrees is a value of 0.4384, and when you complete the multiplication, you should come up with approximately 17.53 miles, which can be rounded up to 18 miles approximately. Therefore, the boat has traveled a distance of 36 miles south and a distance of 18 miles east. That should be your final answer. And please write it as a sentence that the boat has traveled 36 miles south and 18 miles east from the harbor, from its initial position, right?